On this lesson, I prepared some more fractions for you, but this time we will be trying to convert them to decimals. So how can we do that? One way to do it is we have to actually, so the denominator has to be 10 or 100 or 1000, like one with a different amount of zeros. So for example, if we have 3 over 10, we can quite easily convert it to 0.3 because if we look at the decimals, right? If we look at the typical decimal, which looks somewhere like this part is where we write 1/10, right? This is our units. This is our 1/10. This is our 100th. This is our hundredths. This is our thousands, and it keeps going like this. I think you see where this is going. So for example, if we have 3 over 10, then this part would be equal to 3. Next thing, in the next thing, we have 6 over 100. 6 over 100, which as a decimal, so it's going to be this part. You see, so we don't have tenths and we don't have units. What we have is we only have hundreds, like a hundredths part of a decimal. So we write 0 units, 0 tenths, and then finally we have 6 hundredths, like this. In the C, we have, look at this, now we have a whole number together with a fraction. So whole number, we can just leave it like that. We don't have to do anything about it. We have 2 units, then we put a point, and then look at this, we have 5 tenths. So tenths, they come right after the point, so we can just write it as 2.5. In D we have 13 and 7 hundredths. So this, by analogy with B, we can write as 13 points. And then we have 0 tenths, so we just leave 0 here, and we have 7 hundredths in this example. E is going to give us 9 and 17 over 100. So it gets a little bit trickier here. 17 over 100. Actually, we have to fill all the spaces this time. So 17 hundredths. It's like saying there is a 7 hundredths and then 10 hundredths. And 10 hundredths can be basically written as 1/10, like this, if we simplify it. So it's 9.17. And the last one we have is F. In F we have 63 over 1000, which can be written as 0.63 over 1000. Again, it gets a bit tricky when there is like tens or maybe hundreds of things on top of the fraction. So we have to think about, so there's 3,000s, and there are 60,000s, but 60,000s is actually the same thing. 60,000s is actually the same thing as 6 hundredths. So we have to write it as 0.063, like this. Okay, what else do we have? What else do we have here? Decimals as a fractions. So we do the opposite process. Let's try to figure this out. All right, so 0.75. 0.75, again, we can just kind of think about what do we have here. So this is units, this is tenths, and this is hundredths. So we have 7 tenths and 5 hundredths. which together gives us, I can even write it like this, 7 tens plus 5 hundredths, which together would give us, this is 7 tenths is the same as 70 hundredths plus 5 hundredths, which together is equal to 75 over 100. This is what it means essentially. 0.75 is 75 over 100, which actually can be simplified. 75 and 100, you can divide them both by 25. Or if you want, we can actually divide them by 5. So step by step. So we can divide them by 5 first. We will get 15 over 20. And then we divide them by 3. Oh, sorry, not by 3, by 5. We have to divide them by 5. So that we would get 3 over 4. So 0.75 should be equal to 3 over 4. Next one, so actually 0.75 is pretty common if you think it's 3/4. Maybe you can hear it often in English. 0.8 is our next competitor. What can you show as 0.8? So 8 over 10, it's equal to. And 8 over 10, again, can be simplified. We can divide both 8 and 10 by 2, which would give us 4 over 5 as a final answer. Next, we have 0.3, which is the same as 3 over 10, which can be written as 3 over 10. There is nothing we can simplify here. That's it. And then in D we have, I think I'll write it on next line. In D we have 2.25. So again, we can just leave the part which is 2, we can leave it alone. So we write this 2 plus 0.25. And 25 can be written as 25 over 100, which if you divide it by 25, so we simplify it, which will give you 2 plus 1/4. So 25 by 25 equals 1, and 100 divided by 25 equals to 4. So that is 1/4. And then we get 2 and 1/4 as a final answer. In E we have 13.68, which we can write as 13 plus 68 over 100. And 68 over 100, let me think, we can actually divide it by 2 first. So we divide it by 2 first. So that is going to be 34 over 50, and actually we can divide it by 2 again. And we would get 13 and 17 over 25. Like this. This is E. And you know what? F you can try to do by yourself because I cannot fit it here. So F is going to be your assignment. Try it out. What do we have next? What do we have next? We have a decimal addition. So 7 plus, okay, let me copy this first. Okay, so what's important to add decimals is we have to place the point under the point. I will show you what I mean. So 7 plus 0.3 plus 0.06. So we write it like this: 7 plus 0.3, the point is here, plus 0.06. You see, we have to align them on the same line, all these points. 7 plus 0.3 plus 0.06. If there is no numbers here, we can just write zeros. So we write 7.00 and 0.30. And then altogether it's going to be 7 3, and 6. And don't forget about the point. So the answer is 7.36. In B, we have 6.3 plus 7.78, which is equal to, we can write 0 here. We get 8, 0 keep 1, and we get 13 plus 1 is 14. So it's 14.08, like this. And the last one, we have actually a subtraction. So we do 10 minus 0.3. Again, we can add 0 here. And the result is going to be, we have to borrow something from here, but there's nothing. So we take something from here. Then there's 9 left here. Here we get 1. So 10 minus 3 is 7. And then here we have 9. So the answer is 9.7. We will get 9.7 as an answer. All right. And then we have a multiplication. I also have some trick to show you about multiplication. And then we have a division, which is quite interesting. Division of decimals. So first the multiplication, 6.2 times 7. So what we can do here is we can kind of, and here we don't have to align it by the point. We can just write it like this. So what we can do is we can take the point out, but we have to remember how many places we took out, how many places were behind the point. So in this case it's one place behind the point, and then we just do 62 times 7 like we would normally do. So we do 2 times 7, which is 14, right? 4 keep 1. 6 times 7 is 42, and plus 1 is 43. So we get 434, but then we take this thing, we take it back here, this one step, you see, but only one step, not more than that. So the answer is actually 43.4. It's going to be the answer. And let's do B as well. I think we can do B here. 2.14 times 8. So we take the point out, but remember this time it's 2. It's 2 steps actually. We took the point 2 steps out. Let's figure it out. So 214 times 8 is what we're supposed to do. So we do 4 times 8 is 32, right? 2 keep 3. 1 times 8 is 8, plus 3, 11, right? 1 keep 1. 2 times 8, 16, plus 1, 17. So it's 1712. Nope. It's actually 17.12. So these two places, they come back to where they are supposed to be. And the answer is 17.12. Next we have a division. With the point. So 7.6 divided by 4. We can kind of do the familiar process as I just did. 7.6 divided by 4. We can also, but here I think it's going to be better. So again, what I will do is I will do 76 divided by 4, but it should be 7.6. So I just did times 10. So what did I do is I did times 10. We have to remember what we did. We did 7.6 times 10. Let's write it here actually. So 7.6 times 10 gives us this thing, 76. Because later we will have to take it back. So we do 76 divided by 4. 76 divided by 4. 4 comes into 7 once, so we write 1 here. then minus 4, we get 3. And then we do 34 comes into 36 9 times. So the answer is 19. Not really again, so we did times 10. We did times 10, because we did times 10, now we have to take it back from 19. And now we have to do actually division by 10. So the answer is 19 divided by 10, which is equal to 1.9. 1.9. So again, 7.6 divided by 4 is equal to 1.9, like this. Okay, so let's do one more, I think, just to make sure that it makes sense. So 14.43 divided by 3. So again, I write it as 14 for 3 divided by 3. So it's like 1443 divided by 3. But don't forget that what we did to get this, or actually, like, we can also say that we just took 2 points out of it, 2 steps out. So we did 2 steps out, and then in the end we will have to take them back. But this strategy, it doesn't always work, like it gets a little bit tricky. But for now I think we can use it. So 1443 divided by 3. So 1 does not come into 3 doesn't come into 1, doesn't fit, so we write 0. 3 comes into 14. How many times? Actually 4 times. So we write 4 here. We do minus 12. We get 2 and then 4. So 24. 3 comes into 24 8 times. So we just get 84, and then 3 finally gets here. So 3 comes into 3 1 time. So we get 481. And now we have to take back these 2 points. They bounce back. And actually the answer is it's 4.81. This is our answer. You don't have to write the 0 here. So it's 4.81. Okay, this is fractions for you. Fractions and decimals, actually. Everything that's going on between fractions and decimals. And the next topic we will talk about is time and rates of change. So the first question we have is about converting 24-hour time to a 12-hour time. I'm sure you did this in a casual life, because it's a pretty common skill to convert time. I had to do this all the time when I was small. But anyway, I found this handy small clock for you, which we can use actually. Which shows you, at the same time, it shows you 12-hour time and 24-hour time. So for example, 12 is the same as 24 hours, or we actually say 0 hours. 1 is the same as 13, 2 is the same as 14, so we're just going to use it for a reference. And then we have, so in 4.23 a.m. So a.m. is a morning time, and before afternoon, and p.m. is the time after afternoon. Sorry, afternoon. Yeah, before noon and afternoon, like this. So first we have 4:23 a.m. In a 24-hour time is the same as just 4:23. We write it like this: 4:23. 5:30 p.m. So if it's after noon, after midday, we actually have to convert it. So 5:30 p.m. becomes 5:30 p.m. becomes 17:30. 17:30 without p.m., without a.m., just 17:30. Then we have 7:22 p.m. So again, because it's p.m., so the general rule is you just have to add 12. So it's 5 plus 12 if it's p.m. If it's a.m., you do nothing. You just write it like this. If it's a.m., we do nothing. If it's p.m., we add 12. 7:22 p.m. It is going to be equal to 19:22 in the 24-hour time. Okay, next one we have a 12-hour clock time. So in B we have 21 o'clock is the same as 9 p.m. So again, if it's more than 12, you can just subtract. If it's more than 12, then you subtract 12. Basically, if it's less than 12, you do nothing. You just, instead of 2 dots, you can just place 1 dot in there. And a.m. 21 o'clock is the same as 9 p.m. 9:31 is the same as 9:31 a.m. because it's less than 12, and 16:15 is the same as 4:15 p.m. like this. That's the time conversion. Again, probably not a new topic for you. Okay, next we have reading information from the graphs. The graph shows the amount of peas that Mr. Kelly picked in 1 week. A, how many kilograms of peas were picked on Tuesday? So in A, we have to take a look at Tuesday. Oh, sorry, this is Thursday. Tuesday here, and let's find what was the number of kilograms of peas on a Tuesday. So we go here, we connect it to this dot, and then we try to connect it to the vertical scale. And here we have 40, 30, right? So right between them, right in the middle, should be 35, which is going to be our answer, 35 kilograms. B, on which day were most peas picked? So here we just have to take a look at, we can try to analyze this table. And we see that it was 20 here, 35 here, 40. So this one is the highest on this relative scale. And this means that that's when the most peas were picked, which is actually, which happens to be Wednesday. So on most peas were picked on Wednesday. And how many kilograms of peas were picked in the entire week? So we find on Monday it was 20 kilograms. Tuesday it was 35. Don't forget to write unit, which I just did. Wednesday there's 40 kilograms. Thursday there is 30. Friday there is 15 kilograms, and Saturday there is 10. So we do 20 plus 35 plus 40 plus 30 plus 15 and plus 10, and we find how much is it in the end. So it's this is 90 It's 150 in total, 150 kilograms in total in the whole week. Okay, that's the P question. And the last one is actually distance time graphs. It's a nice, interesting question. I'll try to explain it to you. Describe what's happening in this distance time graph. Okay, so I had this picture somewhere which I can use for this question. So what's happening is someone is traveling and distance varies depending on the time of day. Let me use actually, yeah, let me do it like this. So there is 40 kilometers, right? There is 0, and here is 40. I'm not gonna make it super precise, okay? So this is gonna be 10 kilometers. This is here is 20. Somewhere here we have 30 kilometers, like this. And let me find this picture for you. I had it somewhere here. Yeah, the girl cyclist picture. Oh no, this is train. That's too much. Yeah, I have this small cyclist picture. So what happens is we start at 0. We start at 0 kilometers. In here you can see that. This is 0. So she starts at 0. And then what happens in the first hour is she travels to 25 kilometers in the first hour. So now we are here. Then she stays there for an hour. Maybe she takes the break. You see here, the distance doesn't change. Okay, then she travels. She travels another 15 kilometers, and she lands here on 40 in the next 2 hours. She does it in next 2, or actually 1.5 hour. So here in this period, she travels all the way to 40 kilometers, probably from her home. And then also again she rests for a while. So for an hour she just rests here. I don't know, stops. Maybe she's having lunch or something. Just chilling, enjoying the view. Anything can happen. And then so what happens next is she goes back actually. Look at this. She's coming back from 40. It drops down to 30. Right, so she goes from 40 to 30 in the next hour, and then she's kind of like going back. I can't really show it here, but she's going back, and then she rests again. She rests quite a lot on this graph, and this time it's for 2 hours. So for 2 hours again she's just chilling, enjoying her time, and then finally on this part you see in 3 hours she goes back. She goes back to the point where she started. It takes her 3 hours. So this is what's happening in this distance time graph. Okay, that's it for this lesson.